Hello everyone. My name is Yuan, and in Chinese is Yuyuan. So you can find at least not the Hanyu pinyin. Yeah, a little bit different. And I'm one of the Zenoh core developers, and I have 4 years experience with Rust. I'm happy, and I also like open source, and I use NixOS, by the way. Always exploring new technologies, and this one is my GitHub. Okay, so the topic of this talk is introduce Zenoh, a zero network overhead protocol. So what does this for? It's a protocol support pub, sub, and query service that unifies data in motion, data at rest, and computations from embedded devices up to data centers. And we provide a location transparent API for high performance and low latency service. Okay, so the first things to make sure we are on the same page, I will introduce what is a pub sub. So in the real use case, supposing we have several vehicles running on roads, and some cloud service will store the data, or maybe you want to host your models in your private clouds. We want to exchange the data in a very convenient way. So we would use a topic traditionally. But in Zenoh, we use key expressions, which is a superset of topics that we can use wildcards and also attach some computations filter rule in the topics. Okay, so that's why we call key expressions. Also, we support a distributed query that we implement some algorithm inside that we can check what's the condition of the query status and also distribute the queries to the whole networks conditionally. Yeah, you can control it. Okay, so that's what Zenoh's applications, and we aim to make Zenoh be runs everywhere, and it's basically on top of a data link. So it supports the major network protocols like TCP, UDP, or encrypted one, TLS, QUIC, and more further, Bluetooth or serial. Or inside the same machines, you can use IPC or shared memory to obtain the best performance. And in automotive, we also support AutoSAR Classic. Yeah. So in perspective of topology, we can compare with the MQTT, which might be the most popular one, but this one is aimed for the broker scenario. You need to have strong routers. And on the other hand, we have DDS, which is quite common in robots, but it's designed on stable networks inside a robot or wire network. But this is not the final solution for industry-level applications. So that's why we invent the Zenoh that supports heterogeneous networks and also supports various of links. Yeah. So in Zenoh, basically we support 3 major modes: peer-to-peer, and broker scenario, and routed scenario. So you can mix the Zenoh into your desired applications. Yeah. So in Zenoh, this protocol, we are aiming to build up a very huge distributed systems that aim for scalable applications. Yeah. Okay, and we also emphasize the performance. We care a lot about the throughput and the latencies. Compared with other popular frameworks like Apache Kafka and Eclipse MQTT, and also Cyclone DDS, we attempt 3 times higher than DDS and 23 23 times higher than Kafka and 35 times higher than MQTT for latency. So it's quite, our protocol overhead is quite low, which might be at minimal 5 bytes. Yeah. And in terms of latency, we can achieve 10 microseconds in TCP. And for Pico version of Zenoh, it can achieve 7 microseconds with UDP. And 6 microseconds in Zenoh with the IPC. Yeah. Okay. So let me introduce our ecosystem on Zenoh. We are not going to replace other existing protocols. We are going to support all of them, try to unite the ecosystem. So we also support large of databases, and also we can support the web frameworks like RESTful API, and also support the Rust community for robotics. Okay, and we also support a custom runtime, which is called Zenoh. Yeah. So who is using it? First field is robotics. So this one is a survey from the Rust community, and this post says Zenoh is users' first choice for the next generation protocol. Now we are collaborating with Intrinsics, developing a new Rust middleware, which is called IMW Zenoh. It has been in a beta release and will be formal release in the next version of Rust. Okay, so you can check these links, IMW Zenoh. Yeah, we're currently working on it. The other field we are talking is automotive. We have been selected one of the best protocols for V2X by ITU for autonomous and assisted driving. And also we have been selected one of the communication protocols other than MQTT by Eclipse SDV. Furthermore, GM selects Zenoh as the first protocol to implement on U protocol. Yeah, also under Eclipse SDV. So let's go back to the topic of this track, White Rust. A few years ago, we implement our first version in OCaml, which might not be familiar in Eastern side, but OCaml is quite cool, functional programming, and also claims for safety and can be applied on embedded devices. But finally, we go away from it because the lack of the OCaml programmers and the delay support on multi-core. Also, you may curious about why not Go. Go is a popular language for cloud-native applications, and it has Go routines inside, so it's quite good for concurrent programming. But it's somehow poor expressive. It's stupid and boring. You just make things work. Yeah, and I think the pain point is it has garbage collected inside, which may introduce latencies in our applications. This is also spotted in Discord. They have a report on this. And why not CPP? C++ is default choice for system programming for decades. It's not safe, but it's field proven safe. Yeah, and it supports from microcontroller to servers is a wide area, but the package manager is awful. To build something is quite pain compared with a cargo. Yeah, and also you need to be very experienced on GDB because the error logs is also terrific. Yeah. Okay, so finally, White Rust is highly expressive, and the type system is very cool with zero code abstractions. And if focus on memory safety and fearless concurrency. And also for system programming language, built-in async support, quite cool. Also, the async runtime, we could customize this. Okay, so let's check the codes we have. So if you want to try to publish some data with Zenoh, it's easy. And the async SPI is by default. You could open a Zenoh sessions by Zenoh open, and then declare a publishers or declare a subscriber or queryable, any else Zenoh entities with these sessions. And then you just need to call publish put something, and you will automatically serialize the data you want to publish. Okay, and then code await. Simple? Yeah. And the first challenge is how to support both async versions and the sync version. So in Zenoh, we designed an elegant API that if you introduce a Zenoh wait this thread, then you can directly change your original code to a synchronous code by changing the await to .wait. Yeah. Okay. And for the subscriber side, we support two kinds of subscriber. In asynchronous versions, we provide streaming subscriber that you can call the asynchronous code in a very comfortable way. So you can turn your subscriber into a stream and receive the payload and in the loop, and then do something with this. Yeah. Also, if you care about very care about the performance, you can use synchronous versions that attach your callback functions with a callback API. Then you can push this subscriber into background. Okay, so Zenoh is writing in Rust, right? But we have customers from other languages like C, Java, and web development, and Python. So let me introduce the Zenoh APIs that support C. How we support C? We use C by Gen to generate the C codes from Rust, but we need to do some hacks to make it properly. And we also have Zenoh Pico, which is native C. We re-implement the Zenoh logics in C language and aims for the Mistral C for some safety certification. Yeah. And C++ could be compiled with based on Zenoh C or Zenoh Pico. And Zenoh Python, we generate binding by Pio3, which is quite comfortable. And we also support Kotlin and TypeScript. For Kotlin, we use Gemini to generate the binding, and the TypeScript, we used to use GOSIM, but we found that it's too difficult to generate a proper binding. So we currently using a WebSocket to communicate with TypeScript. Yeah. Okay, so in case you are curious about WASM, yeah. So as I said, we try to use WASM, but how to use WASM? We may need to limit our dependencies, like support NoSTD, but we found that it's hard to do it in Zenoh. We are in the opposite way. People in WASM or from the WASM Rust, they may have a goal beforehand that our Rust product will be deployed on a WASM platform, but we're not. We have a Zenoh core writing in Rust, and then we try to compile it into a WASM version, and we need to modify our logic completely. So we're still working on it. And also, we also try generate WASM from Zenoh Pico, from C libraries, but we don't think it's a complete solution, so we're still working on it. Yeah. Okay. So as a network protocol, we definitely support the Wireshark dissector. So its name is called Zenoh dissectors. We used to rewrite the protocol dissection logics in Lua, which is the default language support in Wireshark plugin. Then we try to rewrite them in Rust that regenerates the message types from Rust into C types, so that the Wireshark can directly pass the Zenoh network messages. Yeah. Okay, so provided binding is just a first step. The challenge is, I think, how to integrate with the language system. So when we are coding in Rust, we feel safe if the compiler says okay. But if we change our mind in C and C++, we always need to fight with GDB or LLDB that is stack fault, then we need to trace the exactly line of bug. So about the memory safety, in Zenoh C, Zenoh C++ and Zenoh Python, we place lots of works on make it safe in the user API. But in Zenoh C, you need to do it manually. For example, in Zenoh Pythons, you can call session open and declare publishers. In C++, you do it in the same ways. You don't need to care about the destructions. You don't need to care about the allocations. But in C, we do. But we don't like to force a user to allocate the memory and free the memory by themselves. So we designed an API that try to do something similar in Rust. Okay. So in Zenoh C, we declare some types called the on type. That it's just opaque type, repeat the original Rust data structures. The cloning of the on type is cheap because it's basically a arc of the Zenoh data type. And if you modify the Zenoh data with ampersands, which means you are doing something like mutable barrel in Rust. And we have one mechanism called Zenoh, which maps to the immutable barrel in Rust. And we also have zmove that will move the original Zenoh entities, and zdrop to manually drop it in C, because C will not drop the Zenoh data in Rust. So you need to call it. Good. And some Zenoh entities without the zowned or zview, which is just a reference to a view type of the Zenoh entities, and without the on type, it's just variables on stack. So you don't need to worry about it's free. Yeah, which is quite good. Although this is complicated, but it solves most of the unsafety in Zenoh C. But are we safe now? No, because we found we still could fail a lot in a real usage. Like use after free, we just can forbid the user to doing so, and zdrop an uninitialized object, which just doesn't follow our documentation, but we can't force the user to do it in a C compiler. Yeah, and if you just override the object without dropping the previous one, it will cause a memory leak, which also one we cannot omit. Okay, so let's talk about the runtime. So as I said, Rust is open for customized runtime. It just declare a framework for async API and a feature trait. Actually, you need a runtime to execute it. So we have been a long time for the async STD. Since then, the Tokyo is in a very early stage. on theory, these two runtimes or other runtimes can mix, but we decide to change our runtime from async STD to Tokyo because it's ecosystems and it attains more and more attentions in Rust frameworks. So maybe Tokyo now is the first choice in async runtime in Rust. Okay, so with Tokyo we can control the worker threads on the dedicated runtime. Like we can control the number of threads in application, our application, and acceptor to accept the new links, new messages, and more. And you can control it with an environmental variable. This is quite good. But we also fail some things on Tokyo. First one is there's no sub-milliseconds sleep in Tokyo. So this is quite this bothers us a lot because we used to have this in async STD, but now we don't have this in Tokyo. Actually, we can change the patterns in our code to address this, but it will need some reworks. So we still just live with it. Yeah. And Tokyo context is needed in some plugin systems. As I said, we support some plugins for other frameworks, and in this case, we need to compile Zenoh in dynamical libraries, and we need to determine the context and then generate a Tokyo runtime according to the compile ways you do. Yeah, and plugin in place is needed. That originally in async STD we can directly change the async and sync context by block, which means we can block some asynchronous text to finish. But in Tokyo, we just cannot do it because Tokyo has they have a thread to work as a scheduler, so it's not allowed to block it. You need to block in place. Then mark this thread is maybe blocked. Yeah, it's quite painful. You need to adjust your code and be careful for any violations on Tokyo's rules. Okay. So let's talk about how we support asynchronous version and synchronous versions at once. Actually, we decided we invented an API called resolvable that could be either .await or wait. And inside, under the hood is just called resolve functions. For example, if we want to publish some things, we could either code wait that we call a section resolve put to put something. And in the async versions, which you can call a .await that it just return a future ready and call self.await. So that's why we can support both async and async versions altogether. But you may ask, so does that means all the Zenoh functions are making synchronous versions? No, not at all. Actually, after you call a resolve, it will schedule the messages, so it's still non-blocking. So it's very convoluted. So that's why we feel a lot of pain while we move to Tokyo, because async STD used to have a global executor that can support a plug-on, and you can directly send some text onto it. But in Tokyo, we need to do them manually. Okay, so let's try to demystify the threads we have. Into features is a thread introduced since 1.64. That if you declare implement an into thread for your structures, then you can call .await, just like the examples. And what we do is to satisfy the .await and also provide our custom wait and merge the unify the API with the thread resolve. So this resolve it could be it need to be satisfy weight and into features. And you may notice that we also want it satisfy into sent features because features may not be sent, and this is necessary for Tokyo runtime. We need to make it sendable. Okay, so resolvable means it can be resolved to something that return results. And into send features, just add a send thread onto it, and we implement the into send feature for any T that the T into features is sent. And the thread weight is certified resolvable, can be called weight functions, and finally we use resolvable to unify this, and also implement all the T's that satisfy the previous threads. Okay, so that's why we just need to implement, for example, for the publications, you just need to implement resolvable and then weight and into features. Actually, you can add your asynchronous code into features, and that weight be a plugin version with async STD. Change the async version to a plugin version. Yeah, these are other manipulations. Okay, so what we learned from the futures is futures are not free. We used to have some bugs in the Zenoh protocol because when we enjoy the asynchronous versions, asynchronous functions, we found that finally it will turn it into a very huge features, which occupies a large stack size and somehow be slower. So finally, we have some synchronous part of code and asynchronous part of code, and we want to make sure the critical parts runs as fast as it can, and adjust the size of the stack could be used. Okay. Yeah, we also want to appreciate the funding from the European projects, ICOS and Imperial, that support our projects. So let me make a final remarks on the Zenoh protocols. We are extremely happy with ROS, and the language continues to evolve and comes with new features. And we're also looking forward the growth of ROS into some critical systems. Yeah. And Zenoh 1.0 is going to be released. Stay tuned with our projects. Okay. So, thank you.